Assalamualaikum warahmatullahi ta'ala wabarakatuh. Now we would like to proceed for the transformation of the Laplace. Okay, for the function involving trigonometrics. Previously, we have gone through the function with sine at. But now we would like to proceed with the function of the cos at. By the definitions, it involve the cos at and also the exponent over here, exponent and cos, and then we need to integrate. We taking the limit t approach the infinity, and then finally this is our transformation of the cos at. We will obtain s over s squared plus a squared. Okay, we can compare with the previous one. Okay, as we have the Laplace of the sine at, we will have we will have a over s squared plus a squared. But now for the function cos at, so we will have the difference here only the numerator. We have s over s squared plus a squared. Okay, s over s squared plus a squared. The difference over here can be seen over here, a and s. So let's say if you have a question that need to be transformed using the Laplace transformation. For example, if you have your function of ft is equal to cos 3t. So you need to take in the Laplace for the function cos 3t over here, and then what you need to do is you need to understand to find a over here. So we still have a over here, which is your a is equal to 3, and then finally you will get directly s over s squared plus a squared. So this is the answer. So let's go for the second example. If you have one function of t, so let's say I have 1 over 3. I have here cos 3 over 2t. So as usual, you need to take in the Laplace of that function. And then you know that the 1 over 3 over here is a constant. So you can put outside. So you will have over here cos 3 over 2t. So finally what you will get here, this is your a is 3 over 2, and according to the definition and its answer for the cos, it should be s over here, and then we have s squared plus with a squared. Okay, please be careful over here, your a 3 over 2 squared. So this is the answer. Okay, next we would like to transform the function that involve the hyperbolic function, which is the sine hyperbolic and also the cos hyperbolic. Okay, so here it's the same things according to the definitions. So you have to over here find the limit of this sine function, and finally you will have this one. So this is our reference. So what is the difference between the previous trigonometry, which is the sine? So the sine previously, I put here, if you have sine at, what you will have over here is a over s squared plus a squared. This is for sine, but for sine hyperbolic, this is the one that you need to concentrate. So for example, if you have the function involve the sine hyperbolic, for example, the function of ft sine 3t. So look at here, we have the sine hyperbolic. So as usual, we are taking the Laplace of that function. And then you need to know that your a is 3. So finally, you will have the answer because of the definition give you Laplace, the function sine hyperbolic at will get a over s squared minus a squared. So you already know that your a is 3, and then we have s squared. And then please be careful because we have a negative here, and then should be here is 3 squared. Here is 3 squared. So we go for another example. Let's say you have the function of u in terms of t, 1 over 3 sine hyperbolic 1 over 2t. So you are taking the Laplace of that function, and then please be careful, 1 over 3 only the constant, then it can be bring outside. So you will have sine hyperbolic 1 over 2t, and then the answer is 1 over 3. And then look at here, this is your a over here. So you will have, okay, so 1 over 2 is your a, and then you will have here s squared, since it's sine, because then it should be minus over here. So your a here 1 over 2 squared, and then you will have your final answer. It's similar to our next trigonometric function, which is cos hyperbolic. The difference here is only here. Okay, if you would like to compare with the cos at, the cos at give to you as s squared plus a squared, but for the cos hyperbolic it will give you minus. Okay, let's go to exercise. Okay, the exercise, let's say you have your function of s, okay, let's change, not function of s, function of f over here, ft. Okay, we have cos 3t. Okay, we call it as a cos hyperbolic. So you are taking the Laplace for this function. Remember 2 here is a constant, so you will have cos hyperbolic 3t, and then determine your a. This is your a. So finally you will have, and then you will have 2 here as a constant, and we have s over here, s squared, then your a here is 3. So you can create your own question. You can create your own question and ask yourself, is it the answer that you put is correct or not? Because it's only by the definitions. And then finally, look at here. We can make it a summarize for the table of the Laplace transform. So we go for the single here. So this table can be found in your formula books, and in your assessment letter we will provide for you. So you just need to understand how to transform the single function of the ft over here and transform to become the function of fs. So it's a very easy. What you need to do is you just need to understand how the answer can be determined from this table. I hope you understand. We will meet again at your next video. Thank you.